Hi, I'm Ray, founder at Credo, and today I'm exploring the campus of Caltech, the great American research institution located in beautiful Pasadena, California. It's a quick pit stop on our way to tour Tamarisk Labs, an upstart prototyping factory located just a stone's throw away. I've only ever read about the legendary discoveries made here and wanted to feel the campus for myself. Laboratory after laboratory occupy the beautiful Spanish mission-inspired campus. These are the temples of modern science, where world-changing discoveries in chemistry, computer science, physics, space exploration, and biology all find their origin. So much innovation has happened here, and a bit of nostalgia sets in as I consider the pioneers whose names are now etched in history because of it. People like Richard Feynman, Linus Pauling, and Jack Parsons. How different was their world when they walked these halls? And what about it so moved and inspired them to reinvent it? As I prep for the upcoming meeting with Tamarisk, I can't help but think about the juxtaposition of the two places. Tamarisk, a small upstart leveraging 21st century technology to move fast and iterate quickly. Caltech, the well-funded pillar of applied science that's shown what large, organized action can accomplish. Both places exude an innovative spirit, but one does it fast and one does it slow. One is a model for how innovation was done so effectively in the past, and one a model for how it might be done in the future. With that primer, let's go ahead and jump into our story about Tamarisk and 21st century innovation.
Hi, I'm Emmerich, and welcome to the Tamarisk prototyping facility based here in Pasadena, California. Pasadena as a whole has been a great community for us to be working in, with organizations like JPL, Caltech, Idea Labs based right here. It's been a great area for us to be able to get not only access to amazing talent, but also be a part of working on some amazing cutting edge technology. This is the machine shop. This is where most of the mechanical prototyping happens. The engineers will go in CAD and design different components, and in here is where we're actually able to do small part fabrication so that they can immediately be able to test their designs that they've created digitally. We do all of our mechanical prototyping. So in-house we have CNC machine that's capable of allowing us to prototype small machine parts in-house. And with this piece of equipment, it allows us to actually move really fast on the design side by coming up with parts and being able to test them same day. Over here is we actually have our plasma cutting table. This machine is absolutely fantastic for getting quick prototype components out in steels, aluminum, brass, copper. It'll really do it all. Fixture table will do in-house even welding capabilities of aluminum, steel, stainless. And all of this really just helps us be able to move really fast on the design side and make sure that we're iterating on our engineering cycles really quickly.
Awesome. And what's this sweet contraption here?
This device is a testing rig for one of our clients called Heliogen. This piece of equipment uses a host of sensors, including LiDARs and cameras, to run autonomous software that allows this vehicle to go out and drive over every single one of the mirrors that they have in their concentrated solar facility and actually clean them automatically on a daily basis.
Innovation begets innovation. It's a concept that comes to my mind when walking through Tamarisk prototyping factory. Heliogen, with its mission to decarbonize heavy industry by replacing fossil fuel energy with concentrated sunlight, went public last year in a $2 billion SPAC merger. Moving fast and speeding up innovation cycles is critical for companies like this to compete against the entrenched competitors. And so they partner with prototyping labs like Tamarisk to ensure that the secondary elements of their technology are constantly iterated on and subject to experimentation. It's a virtuous cycle that ensures a constant flow of new ideas and potential discoveries. While Tamarisk might be considered a secondary innovation source for some projects, they serve as a primary innovation catalyst for a host of others. For example, there's a foldable bike helmet, prototyped in-house with the aim to bring safety and convenience to micromobility services like scooters and e-bikes. And there's many other components that make possible products like a self-balancing wheelchair, powered walkers for the elderly, and mechanisms to help scooters and motorcycles lean without falling over. We'll talk more about these projects shortly. But again, it's important to convey the fact that this is all designed and built in-house right here, and in some cases, even designed for manufacturing at scale.
What's up, guys?
Now we're looking at.
Hello. How's it going?
How's it going?
So the product right here is we're doing a small batch run for a company called DermaSweep. They're a medical company that's been focusing on a automated dermatological device. With this is a great example of how we've been able to couple both the engineering design side along with the small batch manufacturing, where they came with a product that was not really engineered with manufacturing in mind. So we've been able to not only deliver them the 100 units that they needed for field testing, but also be able to bring that cost of manufacturing down for when they move to scale. Behind that, there's a company called Hahonu. They're a great example of a company that's managed to merge technologies from two different industries. So they've brought some analytics, some AI analytics to their hardware side, where they deploy in different locations these IoT solar-based tide gauges that collect tide data, send it up to them in the cloud. They have a AI machine learning algorithm that does predictive analytics to help with advanced tide warnings. And this is another great example where we've been able to couple both the design side and the small batch manufacturing, where we've been able to help them through rounds of DFM to get the overall price of the production unit down.
DFM stands for Design for Manufacturing, and it's a critical component of the product development cycle. It's about optimizing a product's design for its manufacturing and assembly process, essentially merging design requirements with the production method in order to reduce costs and ensure future scalability. It's one thing to have a great idea and design, but without an eye for the parts needed to manufacture effectively, it might never reach the shelves, which makes Tamarisk's expertise here such a valuable part of the invention process. Okay, let's go check out some of the other cool projects they're working on.
This is a testing rig for a company called Camino Robotics. They've been at the forefront of spearheading this problem in medical devices with rollators. They've taken the approach of trying to help individuals that need to use either a walker or a rollator have assistance so that they don't actually need to push the device around. This is enabled with motor actuation, so it's electronically powered and is censored to figure out how much torque to put to the motors so that it assists the user and actually actively brakes for the user in certain situations. For example, getting up and out of a seat, the device will actively brake for them to act as an anchor point. When going up and down hills, we'll figure out if it needs to either help assist go up the hill or if it needs to actively brake going down the hill.
There's no shortage of stories of invention here. In fact, every corner of the lab has its own wall of fame of sorts. There's a self-balancing wheelchair, built to enable quadriplegics to move around with head tilts. Tamarisk has our fingerprints on this in the form of a custom robotic gearbox. In this corner over here, there's Exodo, the first of its kind electric three-wheeled leaning vehicle, which enables people to ride without fear of sliding out, an all too common occurrence when traversing on two wheels. It's a safety mechanism that just might transform the way scooters and motorcycles are made in the future. Invention here confronts you at every turn. Each project unique, every story inspiring, and all with Tamarisk's fingerprint somewhere in the design. So how do they make all this with such a lean operation? Well, a big enabling factor is the modern tools they're leveraging. And of course, a lot of hard work and creativity.
We have all kinds of, again, this just goes to show like the wide breadth of industries that we'll work on, the wide breadth of products that we work on. Everything from manufacturing automation. This is actually tied into the folding bike helmet project. In order to get their business model to work, they need to have the assembly pretty much 100% automated. Here what we're looking at is we have a 5-axis robotic arm that we've set up to do testing of automated glue adhesion of the individual sheets that go into the stack of that bike helmet. We have the printers, which you'll hear running pretty much just constantly. We have the form printers, we have FDM printers, we have object printers from Stratasys, which have been really helpful adopting that rapid prototyping technology, and has also allowed us to move really fast. Some of the equipment that we have is in-house. We do not just the mechanical, but we also do a lot of electrical PCB design. So we'll actually, on small batch manufacturing, we'll do internal assembly by getting solder stencils made for the actual PCB board that we're assembling. We'll solder stencil them, we'll populate the components, and we'll actually run it through our reflow oven, so that within the same week versus typical lead times of 3, 4, 5, 6 weeks to get turnaround on assembled boards, we're able to get something that we can test quickly.
I'm not sure if you've caught the drift yet, but the name of the game is constant iteration and rapid prototyping. Two ideas that are sure to become synonymous with 21st century innovation. It's why many are coming along to the idea that we've entered into the fourth industrial revolution, dubbed Industry 4.0, which will be built around modern technologies such as AI, robotics, and the Internet of Things. Today's a sample of what might be possible in this future, given these tools and a genuine passion for making things better.
Yeah, it's a common theme for us, is being able to really get those learning cycles and iterate quickly. It's been probably our number one competitive advantage as a company.
So anyone who has an idea, so it could be an individual, a startup, or even a larger enterprise, you work with all types of folks.
Yeah, we work with everybody down from the individual inventor type all the way through to companies that are publicly listed. As long as it's a technology that for us we find captivating and innovative, it's something that really fits for us. Yeah, I think this is the proof here that we really touch everything from the beginning to the end of the stack in terms of being able to design, prototype in-house, even do small batch capability in-house for field testing and investor demos. And then are also set up through our partner network to be able to move into mass serialized manufacturing when the time comes.
Maybe Tamarisk is a modern day incarnation of something like the famed Menlo Park lab. There must be more similarities than differences. Or maybe this is what the early days at Caltech felt like. Before JPL was a thing, and back when Jack Parsons was just a young kid conducting rudimentary experiments in his quest to build a rocket that would one day enable humans to explore beyond our planet. It feels like this too is the beginning of something big. Rapid technological change will mark this century, and progress will surely be made. But will we worship this technology or use it to improve the human condition? I think this will be a defining question for our age, and after visiting Tamarisk, I feel more confident about the future. Helping people move around, concentrated solar power, and powerful tools for the elderly. For Tamarisk, it's all in a day's work.